All right. So let's talk a little bit about collision detection in Pygame. Now, the first thing you need to do to make sure that you've got collision detection ready to go is whatever object that you're dealing with, you need to get a rectangle object from it. Okay? Because the easiest way to detect collisions in Pygame is to use rects. Okay? Rectangle objects. So there's two types of collisions that we're concerned with. One is an interior collision and an exterior collision. So for example, let's say you've got this object right here and it's moving around your game, but when it hits this edge here, in a lot of games, you want it to stop. You want it to go, oh, I am right here. I don't want to go off the edge. So I want to say, no, you can't go any further. Okay. Or maybe, in a game, you might be inside a room. Okay. And you want them to hit the wall, but you don't want them to go through the wall. Okay. You see what I'm saying? So that's one type of collision where we're on the inside of something and we're going to detect a collision. Now, exterior collision is going to be really similar, but I figured I'd start with this. Okay. So if you've got two rectangles, the way to detect whether there has been a collision is you use this method right here. The name of your rectangle object, or one of your rectangle objects, dot collide rect, and then the name of your other rectangle object. Okay, so these will be changed out with whatever you have called your rectangle object. Okay, now here's the only problem with this method. This method only spits out a Boolean. It only spits out true or false. So it says there was a collision or there wasn't a collision. So you're going to want to check every time, like, hey, was there a collision? Okay, if there was a collision, then what do I need to do? All right. So first thing we're going to do is we're going to say if rect dot collide rect other rect. Okay. So now we've checked to see if there's a rectangle collision. Now the next thing we need to do is we need to figure out where the collision has happened. All right. And this is important because I need to know, hey, did this collision happen on the right side of the rectangle? Did it happen on the top? Did it happen on the left? Did it happen on the bottom? Okay, so this gets a little mathy, so hang with me, all right? So let's say that rect2, I'll use a different color here, hits at the top like this, okay? So the top of the rectangle 2 is hitting the top of the rectangle 1. Well, we can check on this using specific coordinates from these rectangles. So the coordinates we're going to be using most often, we had been using X and Y. Now we're going to be using left, right, top, and bottom. So to access these guys, you're going to do basically rect dot left, rect dot right, and so on. Okay, kind of like we've been doing rect.x, rect.y. All right, so if we're dealing with interior collision, we know that an interior collision has occurred at the top of rectangle 2 if the top of rectangle 2 is the same as the top of rectangle 1. So what we can do is we can say if rect.top equals other rect.top, then that means that there's been some sort of top collision. Which we could do a lot of different things here. We could basically say, okay, if this has happened, then we're then rect2 isn't allowed to go any further. It's not allowed to move past. So maybe we change the y speed to 0 until it starts trying to move in a different direction. Okay. Now, there's a small problem with this. Okay. While this would be really, really nice and really, really easy to just say, oh, if the top equals the top, then it's colliding. The problem is, a lot of times, due to lag issues and other things, a lot of times it won't detect the collision until, say, right here. And if we try to do this right here, where we're saying, oh, does the top equal the other top? Well, we look and here's the top and here's the other top. They're actually not identical. All right. And you'll see some video games where there's glitches where because of lag and because of other things, you can actually go through a wall because it doesn't detect that collision. It doesn't do what it's supposed to do. So what we do in most video games is we create a tolerance for collision. And we basically say, hey, if it's within kind of a little area right here, then we're going to go ahead and say that collision happened. Okay? So the way that we do that, the way that you measure distance, like mathematically, is to subtract. So instead of asking if these are equal, what we're going to do is we're going to ask, hey, what's the difference between these two? So, hey, if the difference between these two is less than, I don't know, some number, then we go ahead and say that this collision has happened. Now, the only thing we have to be careful of now is whenever you subtract like this, it could be positive, it could be negative, and we want this distance to always be positive. So the actual formula for distance is not just subtracting it, but it's taking the absolute value of the subtracting it. So we're going to want to say if the absolute value of rect.top minus other, I'm just going to call it of rect.top is less than what we call our tolerance. Like, hey, how much of a tolerance do we want to give for collisions here? So it's not enough to say that they're equal. We say if the distance, which again is subtracting and then taking the absolute value, that's the distance, is less than tolerance, then we say that a collision has happened, okay, on the left, or on the top. So this would be a top collision. Okay, but that's not the only place that these two rects can collide. We could also have a collision here. We could also have a collision here. We can also have a collision here. So we can also have a left collision, a right collision, a bottom collision. And you'll notice if it's interior, then you're only going to have these collisions if the right touches the right, if the bottom touches the bottom, and if the left touches the left. Okay? So all we do here to do that, we check if there's been a collision, and then we do lots of if statements to detect other possible collisions. So we basically do the same exact thing here. If abs rect dot bottom minus other rect dot bottom is less than tolerance. missing in parentheses there. Then there's been a bottom collision. Now, I'm not going to write this, but you would also want to do one for left and one for right. And you would want to take those and do something based on where the direction of the collision was. All right. So again, if there's a collision on the top or the bottom, you might change your y speed to 0 so that they don't accidentally go through a wall. And same thing with left and right. You might change your x speed to 0. So one last time, you use collide rect to see if there was a collision. And then you see if the distance is less than some tolerance to see where the collision was coming from. Now, you have to be careful with your tolerance. If you make your tolerance too high, then you're going to have someone that's getting close but hasn't actually touched, and it's going to say that there's a collision there. If you make your tolerance too small, then there's going to be a collision, and it's not going to. It'll detect it, but it won't know where it came from, and so it won't be able to do what it's supposed to do. You kind of have to play around and make sure you get the correct value of tolerance so that it acts the way it's supposed to act. Next time, I'm going to teach you how to do an exterior collision.